I'm asked to differentiate natural log. And I know that y prime or dy over dx or f prime of x, we have to get used to all three notations, is 1 over, so the natural log of a function is 1 over the function times the function prime times, it's not a product, it's a sum or a difference of two functions. So cosine prime is negative sine. And cotangent prime is negative, a negative secant, negative cosecant.
Professor?
Yes.
So it was cosecant x minus cotangent x. Sorry.
No, I think I wrote it. So it's cosecant here.
Correct. Yeah.
Cosecant, okay, sorry about that. So cosecant prime is negative cosecant cotangent. So I'm going to erase this. So times negative cosecant cotangent. And then when I differentiate cotangent, I get, negative cosecant squared with minus in front, positive cosecant squared x. I need a new whiteout, which I did buy, because as you see, it started to dry out. Okay, that is gone. Just give me 1 second to get rid of this. Okay, perfect. Good. So I also may have to make a correction here. So I will try to factor because I see something, it's potentially simplifiable. So I'm going to put everything in the numerator. So I would factor out cosecant x over cosecant x minus cotangent x. So if I take a cosecant from here outside, then I have cosecant x. And if I remove cosecant from here, I have minus cotangent x. Remember, I simplified factors. I did not, let me push my device over. So I did not simplify terms. Okay, so then the answer is cosecant x. Very nice. And this is something that you will learn in Calc 2. Now, what I'm getting at, I still see something like this in your work. And I'm begging you again not to do this. I don't mind begging. I have a 20+ year experience. Please do not simplify it in this way, because A is not a factor at the top. Here I can, because this is a factor and I'm simplifying with a factor from the denominator. But A here is not a factor. If you want to separate the fraction, yes, I agree. AB over A, perfect. Plus CD over A. I accept that. So you can write AB over A plus CD over A, and now you can simplify, and you have B plus CD over A if you want to. But you cannot simplify the way this is. Okay? So please do not do that. Do not simplify like that. Okay. Sean, is this okay? You're probably muted. Okay, next question. Thank you so much. Next question. Anything else? If not, I'll...
Professor,
yes?
I have a question.
Yes?
Web design.
Yes?
8.6.
Yes?
Number 18. Had some trouble solving it.
Dylan, was that the one we just did?
I'm sorry, come again?
Was that the one we just did? Was that 18?
What was yeah, let me check.
No, it was the one before. Okay. So, Dixon, is it something like this?
Yeah, it's similar.
Okay. So let's do it. So these are, look at the steps. We did a similar problem during the study group today. This is what we did today, and I'm going to post it. Can I do it at the end or post this and you will look at it first?
Alright, that's fine. We can do it at the end.
So if you have a few minutes after class, let's go over your particular problem. And if anyone would like to attend, that would be fantastic. It's only because it takes a few minutes till I explain step by step. And there is a little trick here that needs to be explained, exactly like what I just said here. So it's not a trick, it's just algebra, but yeah, it will take a while. So if you have a few minutes after class to spend with me, I will work on your particular WebAssign problem. No, I'm not tired of doing it again. I just would like to be able to try to finish the material tonight and Thursday. Is there anything else that you would like to go over? And please stay after class so we can work on that problem. And if I manage to finish, then I'll start it during class time. I promise. I'm not dodging your question. Anything else that you would like to go back to? Anything else? So I will not forget, we'll get back to this tonight. Okay, I would like to work on another problem from 3.7 in which we look at rates of change in different applications, different fields, if you want. And there is a long problem that I would like to discuss. Let me show you. As I said, I have the old edition here. So we have, you may not be able to read. I'm going to read this to you. So a particle moves according to a law of motion. And we have different possibilities here, different functions. And we can choose from your book, from the newer edition, a new edition. So we wouldn't have to choose from here. But I just want to go through the questions. Find the velocity. What is the velocity after 3 seconds? When is the particle at rest? When is the particle moving in the positive direction? Find the total distance traveled during the first 8 seconds. Draw a diagram. I'll explain the diagram. Find the acceleration. Graph the positions. This is with a calculator. And when is the particle speeding up and when it is slowing down? So now let's open on 3.7 and choose one from there, because they may be different. So I'm going to share my screen and look at 3.7 and choose a problem. Here it is. So the question should be the same, but maybe they're giving us a new function, a different function than the ones that are in the old edition. Okay, so here it is. So let's choose from here. Anybody can choose. Okay, now we can. So let's choose a function from here. I would like to assign 2 for homework. Let's choose from the others, whatever you want to work on. Which one?
4.
You said 4. Very good. So let's work on number 4. And we have f of t equals t squared e to negative t. Perfect. So here's the first question. Find the velocity at time t. So the particle, this is the law of motion. We're given that. T, of course, is greater than or equal to 0, is time. And t is measured in seconds and s in feet. So we want first the velocity at time t. So t in seconds and s of t in feet. Okay. So can anyone give us an idea of how, in part 1, how to determine the velocity at time t?
Derivative.
Very good. So we find the velocity is nothing else but f prime of t. If you want s of t, because it says s of t, it doesn't matter. How do we differentiate this?
Product rule.
Yes, so we use the product rule. So if we use the product rule, what do we write?
So 2t times e to the negative t plus t squared times e to the negative t.
Times the inner function prime.
Times, so -1.
That's it. Excellent. Otherwise, I would have to assume that this is e to t, but it's not. Good. Perfect. Of course, I have to figure out that t is a common factor, and e to negative t. T, e to negative t, and let's see what is left. T is out, e to negative t is out, 2 is left. -1, e to negative t is out, t is out, so it's minus t. Or negative, because I am, allergic to negative leading coefficients, e to negative t, t minus 2. Good. So this is the velocity at time t. Any questions, anyone? Okay, back to second question. What is the velocity after 1 second? So what do we do to find the velocity after 1 second?
Just plug in t equals 1.
That's it. So this is 1. This is -1. -1 times -1 will be 1. 1. So it's e to -1. Measurement unit. Yes, we can approximate, but I like to determine the measurement unit. What is the measurement unit?
Feet per second.
Very good, feet per second. Whatever that number is, I don't really care. Good. Back.
Where did you get 1 over e?
I plugged in 1. 1. 1 minus 2 is -1. -1 times -1 is 1. 1, 1, 1. E to -1 is 1 over e.
All right.
Is that okay?
Mm-hmm.
When is the particle at rest? What does that mean, and how do we think about it?
When its velocity is 0.
Excellent. Thank you. When the velocity is 0. That's why I already factored it for us. So it's ready. So here's the velocity. I have -t, e to -t, t minus 2 equals 0. And remember, I didn't write it. Of course, t is greater than or equal to 0 because it's time. Perfect. So then, what do I do now? What are the solutions?
One solution is 2. Other is
0.
Very good. We have two options. T equals 0 from here. This will never be 0, right? So let me refresh your memory for e to t. E to t is this pandemic. So you will always remember it, right? E to negative t is what we want, because this is e to negative t. Okay, this is awful, because that's what we are going through, or we have been going through. So this is e to negative t, but they're always positive. So this quantity will never be 0. So when I solve this, I get either t equals 0 or t equals 2. Awesome. Of course, seconds. So the particle is at rest at time 0, t equals 0 seconds, and 2 seconds later, it will be again at rest. Good. Let me share my screen again. Okay. Parts D. When is the particle moving in the positive direction?
So when it's asking, like, for, in this case, t, do you use each part of it as a separate thing and not in its entirety?
Okay. So let's review something. A. That's why we don't want this. We want this because it's a product. That's why factoring changes a sum or difference of terms into a product. The product is what I need when I have A times B times C, for example, equals 0. Because the sum will not help me. But if I have a product, then I can say either A is 0, or B could be 0, or C could be 0. So I have 3 solutions. So here I have my A, here I have my B, and here I have my C, because they are in the product. This is called the zero product principle. If I cannot factor this, I will have a very hard time solving this equation. Once I factor it, I know a solution can come from here, one can come from here, well, not, and the other one can come from here. So when the first factor is 0, I get that t is 0. When the last factor that can be 0 is 0, then I get t equals 2. Is that okay?
I think so.
Is it better? Because without the zero product principle, we are going to have difficulties. We are not going to be able to solve the equation. But if we cannot factor, then we cannot solve without a calculator and who knows what else, right? Is that clear now? So we are solving the whole thing because we already changed it into a product and we applied the zero product principle. Is that okay? Or the principle of zero product. You can call it either way. Can we go back? Other questions? Anything else?